So now we're going to look at a problem where we go in the reverse direction. We want to find out how many degrees equal 5 pi over 12 radians. We're given a radian measure. We want to convert that to degrees. And I'm going to go through my two methods again here. So let's see, our method 1, which involves a proportion. And I want to find out how many degrees, so I'm going to write x degrees equals 5 pi over 12 radians. And then I'm going to set up fractions in my proportion now, where the denominators give a relationship that I know. I have to have degrees under degrees, and radians under radians. And what I'll rely on is my memorized relationship. 180 degrees is pi radians. And that is going to be the basis of the proportion equation that I solve. Sometimes students have asked, like, how do you know, like, do you use one? What if you accidentally use 360? Is it wrong? Like if you wanted to use 360 degrees. And it's actually perfectly okay to use 360 degrees here where I'm indicating. But then you got to say 2 pi radians, right? Because it's not so much what value you use, it's just that the degrees and the radians in the denominator have to be equal. So I think it's simpler to use 180 and pi, but if you used 360 degrees, then you'd have to use 2 pi radians and everything would be fine. So let's see what this looks like. Now, we got a little bit of a complication here. Because we get a complex fraction, we got a fraction of fractions on the right. And I know some folks find this a little terrifying, and it can be scary when we have fractions of fractions. There are a lot of ways out of this now to solve for x. We gotta solve. And you could cross multiply if that works for you. You can multiply both sides by 180. But I just want to show you one thing I do sometimes. When I get a complex fraction in a problem, I can just take that right-hand side of the equation and write it out as a division problem. Now that's divided by pi over 1, because that pi is not a fraction down below, right? It's just pi over 1. And I can do that division by inverting and multiplying the second fraction. Pi is actually going to cancel here, and I get 5/12. And so what I did was I simplified the whole right-hand side of that proportion. And then I can go back to the proportion, leave the x over 180 alone, I haven't even worked on that yet, and rewrite that right-hand side as 5 over 12. You don't have to do this, but that's just something I wanted to make sure you guys see. And then it's pretty easy here that I can multiply by, now it's easy, multiply both sides by 180, and I have x is equal to 5 times 180 over 12. I think that's 900 over 12, and you can even, you don't have to do that by hand, you can divide that out on a calculator. X is going to equal 75 exactly degrees. So that funny 5 pi over 12 radians, whatever that is, that just stands for, that's another way to say 75 degrees. So here's method 1, the proportion technique. Now we're going to do that same problem using the second method. And you can choose which one you're most comfortable with. Multiply by 180 degrees over pi radians, or pi radians over 180 degrees. the trick about method 2 is you got to figure out which is the right thing to do. And now let's give ourselves some room. So I'm going to start out with 5 pi over 12 radians. And you can think of that over 1 times, I want the radians to cancel. So that's the key here. I want radians below. So the radians cancel out. And so I want degrees up above. I'm going to write out the word degrees so that stands out. So the 180 goes on top, the pi goes on the bottom. So you got to see why I'm choosing the 180 over pi. And we choose it because in this form the radians cancel out and I'm left with an answer with degrees. Now I'm going to write below here too. 5 pi over 12, I didn't, over 1, it's the same as just 5 pi over 12, right? So I could have just written 5 pi over 12 times 180 over pi. And I still have degrees, but the radians gone. And what happens here is the pi cancels, and I get 5 times 180 divided by 12, and you can work that out. It's going to come out to be 75 degrees, same as before. All right, so there's our 2 methods. You choose which one you prefer. You can almost see both methods. Entirely what we were doing was we were finding how many degrees equal 5 pi over 12 radians, and there's the end of the second method.